welcome to this video in the MRDCL Fundamentals series, in which we look at the types of variables that you're allowed in MRDCL and the limitations perhaps of those variable types. So I'm going to take you through an example of each variable type, but I thought I'd start first by showing you some dummy data we've got here. We've got two records, as you can see. The record number is in the first 4 characters. Record 1 followed by record number 2. Now in this data there's each type of variable. I'm going to quickly take you through it so that when you see the script that's going to read this, it'll make a bit of sense to you. So the first field that's going to be in the data is in the 5th field, and that's going to be a single variable where you can see the first record has got a 1 and the second has got a 2. Now the next field that I'm going to pick up is a multi, and if I highlight those columns there, which are fields 6 through to 10, the multi is represented by 1 if it's true and 0 or blank, in this case blank, if it's not true. So having a blank or 0 will make no difference. So you can see in record number 1, the first code in that block of 5 columns that I've got highlighted is blank, the next one is a 1, the next is blank, the next one is a 1, and the 5th one is blank. In other words, the 2nd and 4th codes have been selected. Whereas if we look at the response below, or the record below, you can see they're all true except the second one. So that'll be the second type of variable that we're going to look at. The third one is also a multi, and here you can see we've got the codes listed one after the other. So this is saying that the codes selected are 1 or 01, 03 and 05, and then it's blank in the next 2 fields because there wasn't a 4th and 5th response, but had there been a 6 and 7, it would have carried on as 06, 07. And if we look at the second record, this one has just 2 codes, 02 and 05. Now we refer to this typically as a spread field. Then we move on to looking at an integer, and this field here is an integer. This is in 21 to 24, and you can see the first record has 0020, which in other words is 20. The record below doesn't have any leading zeros, and therefore it's just treated the same as 0010 would be, so 10. The next field that we have in the data here is a field that runs from here to here. So this record has a value of 10.5. You can see the decimal place in there, whereas the record below has a decimal point in a different column, which is perfectly valid, and has the value 25.25. Now we move on to this number here. Now this is some other identification number, which is in fields 31 to 40. So it's an integer still, but it's a big integer in that it's not just a number up to 20 or perhaps slightly more than that even, and we'll cover limits in a minute, but it's actually a 10-digit number. And then finally in this last field we have a name or name of respondent, which is pieces of like a character text, and we'll be picking that up, and there's Mary Jones for the second one. So that's our data. Now let's go to the script that can read that, and I suspect you'll remember some of that as we go through it. So let's look at the script here. So we're reading this data file. We've told it the serial number is in 1 to 4 and the card characters is 4. So let's look at the first variable. The first variable is picking up the data in field 5, which you remember was single. So here we're defining a single variable, and the variable is called single. It's in location 5, and there's codes 1, 2 and 3, shorthand of 1-3. You could say 1, 2, 3 there, the text that follow it, and the title for that particular variable. So in a single variable, only one answer is allowed. There's no way you can have 2 answers. If you had more than one answer, which you could have in certain forms of data like binary data, it would just take the first answer that it found. If you had an E on the end of that variable as an error, it would reject to that error code if it found more than one answer. Now our data here is ASCII, so it can't possibly have more than one answer. So it is going to correctly pick up 1 for the first record and 2 for the second. So that's a single variable, and a single variable can have up to 30,000 responses in one variable. Let's move on now to the next variable. The next variable is a multi. We've called it multi underscore one. And that was the one you remember that was having ones and zeros to indicate whether each of the answers were true. Let's quickly flick back again. You can see here, if we highlight this, so this particular record has the second and fourth items selected. This one has the first, third, fourth and fifth items selected. So the first, third, fourth and fifth means brands A, C, D and E. Now the syntax for that is DM for define multi, the variable name, the location of those ones and zeros stretch from 6 to 10. So that syntax there implies that we're picking up code ones off those block of columns from 6, 7, 8, 9 and 10. We could have put $6/1, $7/1, $8/1 up to $10/1. And the E on the end means anybody who doesn't give any brands, in other words, and none of these categories, as you can see from the text here. So that's one way of collecting multi-data from variables from ASCII data. Let's move on to the second variable now. Now this is the one where we have what I call a spread field. So this is the data that's stored here. So here we go. We have 01, 03, 05 for the first record, 02, 05. So the answers are appearing one at a time in sequence. Now the syntax for that is a little bit different. Again, it's DM for multi underscore 2. It's the first field starts in 11 to 12, so it's in 2 digits starting at the 11th and 12th locations. And there are 5 of them in total, including the first one. In other words, we need this variable to be read from 11 to 12, 13 to 14, 15 to 16, 17 to 18, and 19 to 20, picking up codes 1 to 10. And it doesn't matter whether the codes are sequential or not. The data I showed there had the codes in sequential order, but 06, 01, 02 would be perfectly fine if the data's been collected in that particular way by the data collection software. In both these multivariable cases, again, the limit for the number of responses per variable is 30,000. And just a word of warning there, multivariables do take up more time to run and more space in MRDCL. You may find when you come to do more advanced things that you want to define dummy variables. Now, don't be tempted to define dummy variables of 30,000 codes if you don't really need them. So maybe you're recoding some data from an open-ended question. Don't just set up a dummy variable of 30,000 codes because you know that's the limit. If you only want 20 codes, set up 20 codes as a dummy variable because it will slow down processing significantly, and you might hit some limits if you start making unnecessary variable definitions like that. And I don't mean just one or two. If you start making a few hundred of them, your runs might start to crash if you've got unnecessary variables. So let's look at the next variable. That was the integer in 21 to 24. So here we say di for defining an integer, the variable name, and this means it begins in 21 and ends in 24. Now we need to move on to that field that had the decimal place. Let's flick back to that. So that was the integer we just looked at. Here's the field with the decimal place now. There you can see it highlighted, and you can see we have 10.5 in there. The leading zeros are redundant effectively or make no difference. So that's 10.5 for the first record. Now the syntax for that, we do need a format option before that because that decimal place in there will cause it to reject and set the value to undefined by default. F equals ADF means accept decimal places in fields so that that decimal place is read as a decimal place effectively. So DW$real is 25 to 30. So again, we have a W here. Now it's a bit confusing. That W used to stand for a weight variable. It now actually means any real number or where you may want to have decimal places. So we have DW for the definition, $real, and it will read that with the decimal places. If we made that a DI by mistake, it will just round that to the nearest whole number. And in the case of 0.5, it would round it up. So it's important, if you have got decimal places, that you make them DWs. Now, the next variable is a newer type of variable to MRDCL. This is a DJ variable, and this is a big integer. Now, again, in that data, we had this big number here, which was like a serial number or some identification number of a respondent, perhaps, which was 10 digits. Now, the limit for an integer is 9 digits. If you want more than 9 digits, in other words, you want a big integer, you should use a DJ variable, which is a new variable type to MRDCL, and then it will pick up to 15 digits. And that's been added to MRDCL because there's more record numbers that are that appear in data these days that are longer than 9 digits. Finally, we come to a character variable, and character variables can be up to 2,000 characters in length. This one here is just 20 characters from 41 to 60, and you may recall that was the name of respondent. Now, just to sort of show you how you can take data from character variables, there is this rather strange syntax that if you want to pick up part of the string from the variable called character, we could pick up the first 5 characters there, 1 to 5. You could pick up the 10th to 15th if you wanted to, any part of that character string. I'm saying that if the first 5 characters equals to James, I want to skip to that statement there called jump. And the reason I've done that is I've just defined a second variable here which picks up the same data as the single at the top, because what that will show is that the person James will actually skip this definition and will not record in the variable single their code or answer for the single question at the top, which was about age. Now, just to check this is all working, I've used a list CSV statement with a header, so we get the headers out at the top, and I've listed out each of the variables. Now, there are videos that cover listing data separately, so I'm not going to cover this syntax in too much detail here, but when I run it, you'll quickly see what it's producing for me. So I'm going to close this now. So I'm going to open up the run now and run this, and that should produce for me a report.csv. And if we widen the columns in this report.csv, you can see now that the first record was 16 to 34, and you can see I've got the headings in here across the top of the variables. They chose brand B and brand D. At the spread field, they picked up brands 1, 3, and 5. The integer was 20. They had 10.5. The big integer was 729211, and the name was James Smith. You'll notice the age group is missing here because I jumped round that variable if the name was James, whereas for this record it was 35 to 54, brands A, C, D, and E, brand 2 and 5 for the spread field, integer was 10, 25.25 for the real number. There's the big integer, 22334455, Mary Jones, and the age has come out this time because we didn't skip round Mary's data for single 2. So that's sort of giving you an example of looking at how you can define each type of variable and perhaps looking at listing it as well so that you can check that it's working. And it's a good idea to familiarize all those types of variables before you go too far using MRDCL. Well, thanks for joining me in this video. I hope it's been useful to you. Thank you.